Section 13.3, I got to tell you, I'm so pumped up. I've just been waiting to get to this section. The title is Trigonometric Ratios, and something that I want to talk about for just a second, and that's this word, trigonometric. It comes from the word trigonometry. And as you might have guessed, that tri means the measurement, right? The measurement of a triangle, and specifically right triangles. Well, that's not true. That's not true. As you get further along in trigonometry, you know, it works for oblique triangles as well, triangles that aren't right triangles. But you don't have to worry about that for now. We're talking about measurements of a right triangle. Okay, so trigonometric ratios is just the ratios of the sides of a right triangle. Okay, so let me do this. Let me tell you what those are. There are 6. We're only going to focus on 3, but let me tell you what they are. They are sine, cosine, tangent, and then the other 6 are secant, cosecant, we won't be working with these, and cotangent. I'm going to erase them just as soon as I write them. There are 6, but we're only working with these 3. Okay? Now, let me get rid of these. So we're going to focus on those 3. And I want to give you a little abbreviation. So, ka, toa. Memorize it. Okay? It's going to help us. And let me explain to you what that means. You know what I need to do is move down this example, just so I've got some room to work up here. Okay? Now, I'm going to leave SOHCAHTOA right there, but I'm going to get rid of my, no, I'll leave those trig ratios there. But these things have abbreviations. Let me write the abbreviations in parentheses behind them. The abbreviation for sine is SIN. The abbreviation for cosine is COS. And the abbreviation for tangent is TAN. You may have seen these on your calculator. Okay? Every angle has a sine value, a cosine value, and a tangent value. Okay? So you can punch that into your calculator and it spits out that value for us. Back in the day, we had to use tables. We had to look up the values. But now it's just stored in our calculator, so we can have it just spit it out for us. But let's talk about that for a moment. Let me do this. I'm going to draw a right triangle as best I can here. You'll get the idea. Okay, there's my right angle. I'm going to call this angle A, B, and then this one angle C. And then I'll change the color, and in lowercase letters, I'm going to label the sides. This is side A. Whoa, that's too small. Side A. Okay, it's opposite A, right? The side opposite the angle. We'll call that side A. Okay. This, of course, is going to be side B. And then this is side C. You guys have seen this before. We use it for the Pythagorean theorem. A squared plus B squared equals C squared, right? Okay? Now, these ratios, each one of these angles, not the right angle, but the acute angle, so that's angle B and angle A, they have their own sine, cosine, and tangent. So let's look at this. The sine of A, angle A, is equal to the opposite over the hypotenuse. Okay? Now, if you look at angle A, the side opposite angle A is A. Okay? It doesn't have a value right now. Okay? It may be a length of 15 or 6,000 or 200 million. Okay? Right now, we don't know what its value is. We're just going to say the length of that side is A. Okay? All right? Over the hypotenuse. Okay? The hypotenuse is always the longest side, and it's the side opposite the right angle. Okay? So that's going to be A over C. Okay? Now, let me move this down some more. I'm going to need some more room here. I'm going to need some space. Once we get working, once we get working on this, it's going to, you know, we won't need as much space. But for now, I need to explain a lot of stuff. Okay? So now, that's the sine of A. The cosine of A, of angle A, is equal to the adjacent over the hypotenuse. And the adjacent to A is not the hypotenuse, but the side that's not the hypotenuse. That's the side that makes up angle A that's not the hypotenuse. So that's going to be B. You see, it makes up, it's one side of angle A, but it's not the hypotenuse. Okay? So the adjacent side to A, angle A, is B. And the hypotenuse, of course, is C. And then the last thing for angle A is the tangent. Tangent angle A. Okay? This is going to equal the opposite over the adjacent. Okay? Now remember, the opposite side was A. All right? Yeah. A over the adjacent side, which was B. Okay? A over B. Now, I'm going to stop right there for a moment, and I'm going to point you back to our little abbreviation. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the tangent equals opposite over adjacent. Okay? That's how we came up with these fractions. They're going to be fractions. They're going to give us values for these variables here. Okay? And we'll plug them in and we'll get numbers for this stuff. Okay? Now, let me back up a second. Not back up, but go on to something else. A and B are the two acute angles in a right triangle. Now, you know that this angle is 90 degrees. And the sum of all the angles in a triangle are 180. That means that A and B have to add up to 90 degrees as well, right? So you'll get a total of 180. Okay? So that means that A and B are complementary because they add up to 90. They're called complementary angles. Okay? So let's look at angle B now. I'm going to make a note there. Angle A and angle B are complementary. I'll abbreviate that. Okay? Add up to 90 degrees. Now, let's look at the sine of B, angle B. Now remember, sine is the opposite over the adjacent, but the opposite side of B is little b. Right? Let me back that up. Is little b. And the adjacent side to angle B is C. Okay? The cosine of angle B, cosine angle B, is equal to adjacent A over C. Okay? And the tangent of angle B is equal to opposite over adjacent, B over A. Now I want you to look at this. The sine of A is the same as the cosine of B because they are complementary signs, right? The sine of B is equal to the cosine of A, all right? And now look at the tangents. They're reciprocals of each other. Interesting stuff. It really helps us out a lot. The Egyptians used it a lot for measuring property along the Nile River. They used trigonometry to help keep property lines straight. Okay? Now, that's all you need to know for what we're going to be doing. But remember this, SOHCAHTOA. That will help you remember the relationships, the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right? Now let's go down here and look at example number 1. All right? It says, find the sine, cosine, and tangent of angle A and of angle B. Okay, well, all right. Not hard, not bad. Sine angle A. Remember, sine is opposite over hypotenuse. Here's A, so the opposite side is 8 over the hypotenuse, which is 17. All right, so the cosine of angle A is equal to the adjacent, 15 over 17. And the tangent to angle A is equal to opposite over adjacent, 8 over 15. Okay? All right. Now, remember, just to, bring it back up, if once we're doing angle B, sine angle B, that's going to be the same as cosine angle A. Let's check it out. Opposite over hypotenuse, 15 over 17. Oh, look at that. That's the cosine of A. Cosine of angle B is going to be equal to the sine of A. But let's just check it out over here. Adjacent over hypotenuse, 8 over 17. Same thing as the sine. Okay? You see how it's just the ratios of these sides, how they relate to each other. And remember, the tangent of angle B is going to be the reciprocal, but let's just make sure. Opposite over adjacent, 15 over 18. And that is the reciprocal of that one. Done. That's all they wanted us to do with example 1, is just to put those ratios together. Okay? Now, let's scoot down. Let's look at the next example. It says find the cosine, sine, cosine, and tangent of Q. Okay, well, let's do that. Here's angle Q right here. I see what they're doing. Sine of Q, sine angle Q, I'm sorry. Sine of angle Q is equal to opposite over hypotenuse, right? 6 over 14. And we can reduce that to 3 over 7, right? Cosine angle Q, I'm going to get that right. Cosine angle Q is equal to adjacent. Whoa, I'm missing the adjacent. All right, well, we got to find it. And you know that we can use the Pythagorean theorem. So that means that a squared plus 6 squared is equal to 14 squared. A squared plus 36 is equal to 196. Subtract 36 from both sides, and we're going to get that a squared is equal to 160. Okay, now we got to break down 160. All right, let me extend the page a little bit here. Square root, right? I don't need the negative because it's the side of a triangle. Square root 160, but we got to break that down into root 2, root 80. That's root 2, root 40. All right, root 2, root 20, root 2, okay, I need more space, root 10, root 2, root 5. All right, there we go. So now we're left with root 2, root 2, root 2, root 2, root 2, root 5. All right, that gives us 2 times 2 times root 10. All right, so that's 4 root 10. So the length of this side of the triangle is equal to 4 times the square root of 10. So the cosine is equal to the adjacent, which is 4 square root 10, all over the hypotenuse, which is 14. Oh, that can be reduced, right? Okay. Wait a minute. So the 4 and the 14, that's just going to give us, what, 2 root 10 over 7. Okay, that's good. And then the tangent of angle Q is equal to the opposite, right, which is going to be 6, opposite of Q, over the adjacent, which is 4 root 10. But you know we got to simplify that. We can't leave it like that. So we're going to multiply root 10, root 10, and I'm going to get 6 root 10 over 40. Right? 4 times 10. 4 times 10. And I can reduce the 6 and the 4, turn that into 3 and 2, and I'm going to get 3 root 10 over 20. And that's it. Here, let me get that out of the way just so I can see that a little bit better. All right. Okay, got to use Pythagoras, got to use all the rules for radicals that we know how to use. Okay, that's a nice job, guys. That's nice work. Now listen, I'm going to have to stop this video and pick up the next 2 examples on the next video. All right, you guys are doing a good job. Keep it up.